What's up, everybody? Welcome to Flux Harmonic. I'm David Wilson, and today we are back with another regular Thursday stream. Obviously, today is Tuesday, yeah, we're going to get into some more live coding as we normally do on these streams. And last week we started focusing more on the graphics side of the equation to kind of expand what we're doing there. We worked on general rendering. I think it was last week, wasn't it? We started that, or was it the one before? At any rate, we did start working on getting our expanded OpenGL-based rendering with GLFW working, and also we started getting PNG loading and saving working on the stream. Last stream, we got to the very end where saving was almost working, but this file had like empty contents. We'll talk about the resolution to that in just a moment, but I'm glad we have at least gotten past that point because we've been sort of circling this area for a while now. And now in this stream, what we're going to try to do is lay the groundwork for TrueType font rendering or OpenType or any other type of, sort of modern font files that we might want to use for rendering fonts inside of video thumbnails or just anything else that we might want to create with Flux Compose. So I'm looking forward to getting this working, mainly because this is going to be one step closer to using Flux Compose for generating the thumbnails for videos and also for other types of graphic design and things that I might want to do with the project. So looking forward to getting this working. So let me just jump into the first updates here. So first of all, I did create a Discord for the channel. So, for the community of people who watch the streams regularly, there is a Discord. The link is here on the screen. It's also in the description and in the chat right now. If you're watching this live, you can click the link and then join the Discord there. And the whole idea here is that while we're not on the streams, we can still discuss things about graphics development, audio development, game development, making scripting languages, all of the things that we sort of do on this channel. We can get together and discuss those things on the Discord. So I think it'd be cool to, have a separate place from the System Crafters Discord to discuss all this so we don't kind of clog up that Discord with it. For those of you who are more inclined towards, free software solutions or more open protocols, the reason why I'm using Discord for this is because, the space that I'm working in this channel is a bit broader than what I do on System Crafters, in that, there's people who are doing game development, graphic development, that kind of thing, who don't really focus too much on free software, that type of thing. So I want to make a place where more people can join and be involved if they're not really interested in what we talk about on System Crafters. So Discord seemed to be the best place for that. So that's why I've created the Discord for the channel. Hello to Daigo and Mr. Bill. Thank you so much for being here. Also, PNG saving now works. I actually managed to fix it about 15 minutes after the stream, or like whenever I finally had a chance to look at it again. It only took about 15 minutes to fix it. It turns out what I was doing was, let's see, save. Let's jump to that. Oh, let's get eglot running here. All right, so if I jump to the definition of this, then the thing that I was missing last time is I was not setting this color type variable on the header for the PNG image. Once I finally set that to the true color alpha color type, everything rendered out and I was actually able to see something in the file. However, the interesting thing is that because OpenGL uses a flipped coordinate system compared to what you normally expect for screen coordinates, usually the screen coordinates for 0, 0 are at the top left of the screen, but OpenGL likes to flip that so that 0, 0 is at the bottom left corner of the screen. So when I wrote out the image data to the file, the PNG file itself was flipped so that it was like upside down basically. So I had to write some extra code to address that issue. Let me actually see if I can find where that was. Let's see, reverse, no. It's in, I think it's in graphics. So graphics.c. Yeah, so I had this for loop that basically just reverses the order of all the rows of bytes in the image data, and that solved the problem. However, it's kind of interesting that the author of libspng somehow managed to find the stream recording from last time and left a comment basically saying, telling me how to fix the first problem, which we had, but also telling me that if we use the progressive encoding functionality of libspng, we could actually deal with this flip of the image data as the encoding is happening. So I haven't tried to do that yet, but it is something I'll try to do pretty soon and see if I can get rid of this extra step where I go and flip all the image data before saving the file out. But that's really not a major concern. Right now it actually does work. In fact, if I go look at the output.png file that I have here from, that's still out of date. I've made some changes to the code since last time, and it won't render perfectly, but it will render something. So let me just try to build and run really quickly and see what happens. All right, so we're gonna run the example. Geeks is gonna have to pull something down really quickly. Okay, so that should get things mostly done. I'll talk about the changes you're gonna see here in a second, but let me close this out now and then try to open up output.png. Okay, it did actually render what we have there. So we can now render a PNG successfully, which is great. One thing that's kind of interesting about what you see here, I don't know if I can zoom this in very easily, but this green rectangle has some alpha channel on it, and apparently it's blending all the way through to the base layer of the image, so that it sort of makes the image sort of slightly transparent under this, and also makes the red part slightly transparent too, which is kind of weird. But that's probably something I can look into as far as like setting up the OpenGL blending modes correctly. But this part is strange, but it's just things we'll figure out later. Just kind of an interesting aspect of that. But it is nice that we have the image data rendering out successfully now, because that means that once we get the text rendering in place, that plus the image rendering plus some other primitive drawing would actually allow me to get pretty close to rendering out the kinds of thumbnails that I make for System Crafters videos and for the thumbnails of these streams on YouTube. So we're getting really close to actually having a basic thumbnail generation code working, which is great. Let's see, what else was I going to talk about in this section? Dear Ed always messes with my key bindings. So I also, was hacking around a little bit on the project off stream, and I added some code for rotating and scaling rendered textures. So if you go and look at what I did just before, you can see that this Flux harmonic logo is actually scaling and rotating periodically. It's basically just using the sine function to take the current time and use it with a sine wave to just make the scale and rotation animate a little bit. So it's kind of a nice little feature to have. And that was kind of interesting because I started dealing with GL push matrix and GL pop matrix. GL push matrix. GL push matrix GL push matrix and pop matrix are pretty interesting functions where you can sort of push the current model view matrix onto a stack and then start tweaking the current matrix for the model view. So basically what things are being rendered on the screen, and do things like scale and rotate, and then draw whatever you want to draw, like rectangles or textures or whatever, and then pop the matrix back off so that you get back to where you were before you actually did those translations. So, or those transformations. So that plus using these things in a couple of different places allowed me to do something like, do the movement on that sprite that you saw. But also I can do things like scale the entire view. So if I go back and try to look where I have that. So I have a scene view concept that I added also. I can make this scaled up by, let's say 1.5. If I restart this, now the scene is actually rendered bigger, you can see. I can go and make it 2 if I wanted to, and it would be even bigger. Now, right now, these are not being, what did I do wrong? Oh, 2.f. Right now, I can't actually change these dynamically at runtime, and it retains the current scale no matter what the window size is, and this is sort of by design because I want this to be sort of like an image editor program where you can make the window bigger, but you're still looking at the same size image, but you can zoom in and out if you want to. So we're going to add some key bindings at some point soon to make it so that we can scale in and out or zoom in and out on the image we're working on, and even pan around in case we want to look in more detail at some part of the image. You can even make it smaller if you want to. I can make it 0.2, and all the rendering that happens inside of that thing is scaled to the actual scale of the whole view effectively. So it all is consistent with what you would expect it to be at that size. So it's kind of nice that I have that ability just by virtue of the functionality of OpenGL to scale like the entire thing that I'm drawing And also I can scale this part of the view without scaling other things that I might draw on the screen. At some point, I'm going to have some kind of diagnostic UI elements on the screen to show information about the things that are on the screen currently, or maybe the current FPS that's for what's being rendered. That stuff can all be rendered without being affected by the scale of the actual preview area that we're drawing. So it's kind of nice that you have this capability with OpenGL to control which things actually get affected by the transforms you're applying. Let's see. And I mentioned also that I made the preview area center itself. That was another thing that I didn't actually show or call out. Previously, we were just drawing the preview area at the top left-hand side of the window, but now when you resize the window, like I'm making it full screen here, you can see that the preview area still stays in the center, which is kind of nice if you want to be able to see things bigger, and maybe you want to have full screen view and then zoom in a little bit more. You always stay centered effectively. We may change that later if we add panning of the view, but by default it is centered. And this little yellow rectangle basically is drawing the size of the target image effectively. All right, that is that, I think. So today what we're going to be doing is using the FreeType library that's been around forever to load up a TrueType font so that we can extract the glyphs for each letter. And a glyph is basically the shapes that are needed to draw a single letter of whatever textual characters that you want to draw to the screen, like A, B, C, D, E, F, G, etc. Each of those has their own glyph. And we can use the FreeType library to basically render a bitmap of each of those glyphs and store them as OpenGL textures. And once we have those textures, we can then render a particular string to the screen just by using those textures that we've extracted from the font. So we're going to try to write as much of that code today as we can. I don't know how much we'll be able to get done with, but I've got a good tutorial that I'm going to follow. Excuse me. We're going to be looking at this tutorial as we go and picking up some of the ideas from there, which I think is totally fair game because I don't really know anything about this library. So we're just going to try to jump in and start using it. Some of the things we're going to have to deal with is storing information about all the characters we might want to display. And because we're going to be using a font that's not a monospace font, each of the characters can be different widths and heights. So we're going to have to be able to deal with rendering these different characters to their appropriate width so that the text looks right. Otherwise, if you render all the characters to be basically the same width, you're going to have weird gaps in between letters and the font won't look right. So we're going to have to deal with something called kerning to a basic degree. Now, I don't really know if we're going to be doing literal kerning, because from what I was reading online, kerning is where for a particular typeface, like a font, kerning says that for two particular letters that are next to each other, there may be customizations for how close together those should be. So we may not deal with actual kerning today, but in this case, I'm thinking of kerning in terms of how much width each letter takes up and how much space there is between the letters. So we'll deal with a little bit of that, I think, just to get something basic working, and then later we can polish this if we need to based on the desired results we need. Also, eventually we'll need to deal with locating fonts by name by using the font config library. That's another long-standing library that can help you search for installed fonts on a Linux system. Not sure how it works on Windows or Mac OS, but I'm not really concerned about those right now. But font config can basically tell you all the fonts available so that I can ask for a font by name instead of having to give a file path. The FreeType library expects you to basically give a it expects you to give it a path to a TTF or OTF file, and I don't want to have to do that every time, especially because I'm using Geeks and the file paths to TDF files are crazy looking. So better if I can just use the name of the font and then use font config to actually resolve that and figure out the actual file location of the font file. And we're not going to be adding things like text wrapping or alignment yet. We don't really need them yet. So we're just going to write code that will render a string, every character of a string from left to right. Firelights asks, it seems like a good challenge, but is there an actual advantage to doing this over the easy way? Only in that I have full control over how text gets rendered, and also I get to learn a little bit about this because I've never written a renderer for variable width fonts before. I've written multiple bitmap font renders in the past, but I've never written one that uses TrueType fonts and renders out the glyphs to textures. So that's something that I kind of want to do, and we're just going to use this as an opportunity to do it. Now, if it turns out to be overly complicated, we may switch to using a different library for that, like let's say Cairo or something, or Harfbuzz. But I don't think we'll need to go that far. I don't really have super high expectations from font rendering at this point. I just need to be able to render some text on the screen and have control over where they're positioned. So that's all I really care about right now. And I think it'll be fun. I mean, that's like I keep saying on this channel, the whole point of all this is to do things from scratch because I want to, and because I kind of like having more of the functionality of the code be part of my own code base and not coming in from third-party libraries. So I'm just trying to avoid things that I consider to be unnecessary to pull in external libraries for. Just my own personal preference. All right. So the tasks. First of all, we need to try to figure out how to use the FreeType library to load a font. And then we're going to use the font that we load up to render glyphs to OpenGL textures. And this whole part might take enough time that we, reach the end of the stream, but we'll see how far we can get. Then we're going to write a function that can render a string by indexing the texture for each letter of the string. We're basically just going to expect that we're only dealing with Ascii characters right now, just, the alphabetical characters plus numbers and symbol characters that are, typically used in Ascii text. We're not going to worry about Unicode or anything like that. Maybe later, but I don't really have a big need for it at the moment. Also, maybe improve the kerning or the spacing of the text depending on how it looks. We may also make it configurable if necessary, but I don't really know yet whether that will be necessary. I keep saying necessary. And then we could try adding a nice gradient to the rendered text if we get to this point. Like if we actually get text rendering, we can add a gradient to it. Pretty easy to do with OpenGL because all you got to do is just set the colors on the vertices of the quad for what you want, and then OpenGL will produce a gradient on your behalf. So we will give that a shot later if we manage to get to it, and then we'll do it maybe on Thursday too if we don't get to it today. It's not really needed exactly for the types of thumbnails I make for now, but it's kind of a fun thing that we could do fairly cheaply, so I figured it would be cool to add it. And then I have some notes here for the references that I'm going to use for this. Oh, do you hear the music in the background? I see that I have my audio muted. I'm not sure which audio is muted. Okay, I think it was a different one. All right. So let me paste this link in. This learnopengl.com website is a really, really good resource for learning more about, I don't know, Object-All. There we go. Have to deal with this all the time. It's a great site for learning pretty much everything you need to know about OpenGL. It goes not only into the basics, but also goes into a lot of more advanced features that you might want to do for high performance rendering. And font rendering happens to be one of the things that they cover here. So I'm very happy that they have some more information on that. They cover bitmap font rendering at first, which is pretty straightforward. We're not going to deal with that unless we need to at some point. But we're going to deal with the modern text rendering approach using FreeType. So this says it's actually available to use on macOS, Java, PlayStation, Linux, and Android. That's cool. Not Windows, apparently, but I guess there's other solutions on Windows. And I've already got FreeType pulled in. I spent a little bit of time before the stream today to make sure that all the dependencies are loadable, because I don't want to have to sit around here and try to figure out how to build the code with FreeType. So I went ahead and did that ahead of time. But one thing I do need to do is run geek shell pure manifest.scm and then run bootstrap here just in case, because I want to make sure we get all of our code completions and whatnot from the FreeType library. And that should be enough for that. And I've also added this font.c file, which really has nothing in it right now. Yeah, this thing keeps complaining. I don't know what's going on. Undeclared identifier. Can we just make eglot workspace, restart, shut down? Okay. Let's see if this works this time. I think that's better. If I use go to definition on this, okay, good. So it actually does find stuff now. So this is just the bare minimum code we need to get FreeType started, but we need to do a better job of getting this all pulled in. So let's see. Entry point. Let's think about how we want to get in here first. So Flux font load file. First of all, I need to find the font file that I want to load. And I'm going to go into my GNU store folder, GNU/store. This may take a moment to load up because there's a ton of files in here always. I'm going to look for the Jost font. And we're going to go into share, fonts, TrueType. And we're going to pick one of these. I don't know exactly the right weight, maybe 600. Or we'll pick the medium one. So I'll copy this file name. And I'll also copy, how do I get the path? Copy the path as well. This is probably not the right, not the right place to put this in. Let's go to Scratch instead. So I'm just going to drop that font path in. I'm going to grab this too. So I need to have a path directly to the font file. That's the reason why I'm actually doing this right now. So let's jump up to the equal sign, make that a slash. And now if I were to try to, oh, come on. If I try to open this font file directly, will I find it? File not found. Okay, cool. Yeah, it's got some kind of weird character at the end. So that should be enough. Let's go into graphics.c where we have our horrible hard-coded stuff inside of the main render loop, which we're going to eventually move out. I just haven't gotten to it yet. And we're going to load a font here. I'll do that after all the context stuff is set up. So let's say load a font. And I'm going to put in the string for this path. And this is why I want to eventually... wow, why did it do that? I guess that's a valid thing to do in C, where you can just have two strings that just get truncated like that. Okay, we'll fix that in a minute. So let me jump down to put this back to compilation buffer. So we need to go into font.c. Yeah, we want to be able to just load that font file up and then be able to use it to render something at some point. All right, so Flux font load file care font path. We probably want to have a struct for Flux font. In fact, I can probably just do, well, let's do this, Flux font. And then, don't really need a name, I guess. Don't really need a size. I probably just need the handle to the font itself. But what I'll do here is, let's see, return a Flux font. And what I'm going to do is make a type def for Flux font so that it has the pointer attached to it inside of flux.h. So texture, let's also make a section for fonts. Just fill in some space there a little bit. And then we'll do Flux font. I don't know if this is like the best approach for setting up new types, but this is just the way I'm doing it here. And then we'll want to copy this signature as well. We're going to extern that. Flux font load file. We probably need to also specify, well, we're going to need to specify size at some point, but that's, I don't think that FreeType deals with that. I think that that's actually something font config would deal with. We can actually, let's just say uint 8t font size. We're just going to say font size for now. We may need other parameters here later for like font weight and whatnot, but this is enough for just the present moment. I'll copy this little bit, put it back into font.c at the end of this line. Then I'll also pull in the int types.h. All right, so now we need to be able to return a Flux font, which means we have to malloc the Flux font whenever we're ready. Let's see, Flux font, font, or we can just say Flux font here, equals malloc size of Flux font. And then we can return Flux font. So that will give us just the basics here. So initialize the font in memory. Also, we want to load the font file with FreeType. So let's go to the tutorial and see how we should do that. So we can say ft new face. So there's this ft face here. That's cool. I can actually just grab this little snippet there and paste it in. We're just going to do a little bit of copy pasting on this stream. You know, normally I wouldn't want to do that, but since it's just, you know, very simple stuff, there's no reason for you to watch me just type this out. So we'll say flux log, and then failed to load font. I'll put the font path in here as well. And what do they call it? Font path. And then I'll change this to be the font path as well. So this is font path. Also with FreeType, I need to not reallocate this every time. So can I do like a static here? Would that work? Or is that like a terrible idea? We'll see. We'll see if static here is a bad idea. FT library FT. If I never need to call that again or use that again in any other function, that should be fine. But we'll see whether it's necessary. It might end up being necessary. So we initialize FreeType, which, you know, does some bookkeeping, I guess, behind the scenes, allocates some memory for FreeType, and gets the library ready. Then we're going to try to load the face using ft new face, pulling it from the font path. Let's see. Each of these FreeType functions returns a non-zero integer when an error occurs. Once we've loaded the face, we should define the pixel font size we'd like to extract from this face. Okay, so we can actually do that. That's cool. So based on the font size, let's see. Specify the size of the face needed. So we were going to put font size here. I don't know if that's the appropriate parameter for this. Let's see. What does it want? Okay, it wants an FTU int, so probably that's fine. And then we can start loading the characters for the font. So that's cool. FreeType face holds a collection of glyphs. We can set one of those glyphs as the active by calling ft_load_char. So we're making a little bit of progress so far. It doesn't seem to be that hard at the moment. Let's set up char Ascii. Well, no, we don't need to do that. Define Ascii char start 0, which is wrong. Define Ascii char end 0. So let's take a look at the Ascii character table. I think that's a good one right there. So what we want is just to make sure we pick up the right set of characters. We want to start at, let's see, ASCII characters. So I think 32 is where we're going to start because we want space. So we're going to start at 32. And these are all ordered integers that are monotonically increasing, which basically means they increase, they ascend by 1. And there's all the punctuation we might need, digits, some more punctuation, capital letters, some more punctuation, lowercase letters, and more punctuation, and then it ends up to tilde, which is or tilde, which is 126. So we can go just that far, I think. So we're gonna stop at 126. So that's the set that we're going to render. But first, let's just start by trying to pull out one character. We'll just see what happens by pulling out one character. So ft_load_char. We'll just do this little snippet as well. So let's see. Load glyphs for each character, but we're just going to hard code 1 right now. Oh, wow. So it wants a character. I guess you could probably just put a number in here as well. So I'm going to put 32. Nah. Well, okay. 32 is not very interesting because it's space. How about we say A? Let's just do the letter A for now. I don't know why Emacs is completing these single quotes like that. Okay, excuse me. So load char face A. I'm guessing this ft load render is a flag. That means we're loading it for the purpose of rendering a bitmap. We will clean this up a little bit as well. We'll put our flux log. Let's see. Failed to load glyph. We'll put what the character was for that. In fact, how about we do this char ASCII char equals a. Just take this because I don't feel like dealing with the quotation marks again. ASCII char. And then here we'll also do ASCII char. And the reason why I'm doing this is so that it's easier to replace this with a loop in a little while. All right, let's put a new line on this as well. All right, that's enough for loading the glyph for the letter A, capital A at least. All right, so what this says is that by setting ft_load_render as one of the loading flags, we tell FreeType to create an 8-bit grayscale bitmap image for us that we can access by a face glyph bitmap. Cool. So basically, that's just the image data we need to throw into an OpenGL texture. Now, the article here has a very helpful diagram, which tells us about some of the metrics that are necessary to use for each glyph in terms of how that affects the spacing around the text and how it's aligned based on the location where the text needs to be drawn. So it's kind of a useful thing to take a look at. Let's see, anything else interesting to mention? Each of the glyphs reside on a horizontal baseline. So we need to deal with a baseline for where the text gets drawn. Where some glyphs sit exactly on top of the baseline, like the letter X, or some slightly below the baseline, like G or P. So sometimes you have letters that have parts that go below that baseline. And these metrics define the exact offsets to properly position each glyph on the baseline. So we're trying to render every letter on some fixed Y position, and we're adjusting them to make sure that the parts of the letter show up in the right place, like G and Y and P, those that have the whatever that you call the piece that sticks down below the line, those should be placed in the right position. So the properties we need to keep an eye on are the width and height of the bitmap itself, which we'll need for texture rendering. Also the bearing X and Y, which is the position of the bitmap relative to the origin. So I'll figure that out in a minute. And then advance, that's sort of like let's see, let's look at this right here. Advance is the amount of space needed, I guess, between the letter and the next letter. Bearing X is space from the base to the beginning where this letter should be drawn, I guess, yeah. And bearing Y is how tall it's going to be. So we can load a character glyph, retrieve its metrics, and generate a texture each time we want to render a character to the screen, but it would be inefficient to do this each frame. Yes, exactly. So we're going to basically store the information for this in a structure that will allow us to retrieve it easily. All right, so yeah, they're restricting themselves to the first 128 characters of the ASCII character set. Yeah, that's basically the right thing to do. All right, so what they are doing here is, let's see, unpack alignment, disable byte alignment restriction. Ooh, that's interesting. And they've got a nice little loop that deals with generating the textures for each of those characters, similar to what we're doing right now. They just set the current character based on the index of the ASCII character they want to render, and then they create a new texture and render the, let's see, where is the, yeah, bitmap.buffer. So they just take the bitmap information for that face and then render it directly into that texture that they've created. And let's see, what do? They set texture options. Yeah, okay, so they're basically making the texture render correctly by setting certain options. And that gets set on that texture and remembered, I think, by the system, if I'm not mistaken. And then they store the information for the characters. Okay, so that's basically all that we need to do. So for a given font, we're going to need information for every character. So let's say we're going to need a type def struct flux font char. Hi, Richard. And let's say we don't really need the information about what character it is, I'm guessing. So we need some of the same information, like the, what do we want to say for bearing X? Is bearing, let's take a look at what's in the face. So ft face, is that an allocated thing? Do we need to use an indirection operator on that? I think we do. All right, I guess I had the code right here in front of me. Face arrow. Give me some intelligence. Thank you. All right, cool. Bearing. Oh, come on. Bearing. Let's see. What are we missing here? Oh, glyph. Okay, I gotta go into glyph first. Glyph. Arrow. Bearing. No, it's not giving me anything. Bearing X. Let's see. Oh, bitmap left. That's what it is. Okay, so the terminology being used in the article is different than what is actually, yeah, given by the library itself. Okay, so we have bitmap left, and what type is this? It's going to tell me. Equals 0. Let's just do that and see what it does. Int. Okay, so it's just an integer, which makes sense because it probably needs to be negative as well. So let's say int 8t. Is that a valid type? Or is it sint? What is the signed integer type? So int types.h. If anybody knows, or is it cint? Come on now. Come on. I don't want to log in. Obviously, I don't know Greek enough that I'm having trouble clicking the right buttons here. Hey, Benoit. So uint int 8t. Oh, come on. Int 8t. Where is it? Oh, is this standard int.h? Is that what it is? I'm probably including the wrong ones. It is int 8t. What's the problem? Oh, I guess I just need to continue writing here. So bearing x. Okay, of course. Int 8t bearing y. What else do I need? I need to have the advance, int 8t advance. We'll check the types of these things in a moment because I think we might need to make sure we're using the right types for all the stuff that we're pulling in. Oh, okay, so advance is an unsigned int. And yeah, we need a texture ID as well. So uint 8t. I don't know what type that texture IDs are. Texture ID. We may have to take a look at that one in a moment. And this was also supposed to be an unsigned int. All right, so for every character, what we want, let's actually do this. We'll move this up to the top. And we're going to have an array of Flux font char for a size of, I don't remember if the array is supposed to be on the name or not. We'll figure it out. Characters or chars, I guess you could say. ASCII char end minus ASCII char start. Maybe not the greatest idea, but we'll go with that for now and see what happens. Must use struct tag. Oh, okay, right. So let's change what I did here. It's actually wrong. We're going to put that here so we don't have to use the struct keyword. All right. So that seems okay now. And that's basically the information for all the characters. And I don't know why they're using like a map or something, or they said they were using a map in this code. They're inserting it for the C when you don't need to do that because you already know the index. So you're just indexing into an array. It just doesn't make any sense to me why you bother to use a map for this. Just whatever. Benoit says, "Wow, C. Yeah, we're writing C in this channel." Okay, so that's enough for the initial data structures that we need for that. So in this case, we could start populating the information. Maybe we should just go ahead and put the for loop in. We will set an, I mean, we could say char here, honestly. Char current char equals, we'll say 0 to start with. And then here in the for loop, current char equals ASCII char start. Is that what I said? Load the JVM to run closure and use Eden structures. No thanks. Current char is, well, actually, we probably need to do a +1 on that, right? ASCII char end +1. Current char ++. Come on. And then we can drop that below, indent this a little bit. All right, so load the character glyph and information. And now we can start setting up our own care. We probably want to mem set this. In fact, we probably need to put this earlier as well. We need to initialize the font in memory. And then for Flux font, the cars array, we want to use memset, I think, to just zero everything out. We don't want to have that to be all messy. So is memset in standard lib? Include standard lib, or is that in string.h? One of the things that makes no sense to me. Let's start with string.h because I think that's where it is. All right, so memset Flux font cares. Are you gonna give me signature help? Thank you. All right, so the size. So size of Flux font cares. I think that should work. And then size t in in bytes of S to C. Let me check other usages of memset. Memset. Size of header. Okay. So just 0 as the second parameter. Okay, fine. Oh, right. That's the value you want to put in there. Okay. So we're just zeroing out that whole array because we don't really need to do anything. In fact, we could zero out the entire Flux font if we wanted to as well. Maybe we could just do that. Just to be safe, because we might add more things to that later. And we'll say size of Flux font. Okay. So now we've got a blanked out Flux font data structure. The array is all blanked out. And what we will do is start plugging things in directly. So on Flux font, we can say current care. Oh no, Flux font cares, current care dot, and then whatever's in there. Okay, bearing x equals face glyph, and what was it? Bitmap x? Is that what they were calling it? Let's go check out what was in the tutorial here. I don't see them storing that information. Bitmap width, bitmap rows. What do they have? Size is the first one. Okay, yeah, fine. So we need to have not only that. I really need a vector type. That's for sure. It's starting to show that I need a vector type. Size x, size y. Benoit says nice C Emacs configuration. Yeah, it works pretty well. We actually have code completions and, you know, navigate to definitions, etc. It's all great. Okay. So, is that the right one? Bitmap X? Left. Bitmap left. And then bearing Y is bitmap top. Yeah. All right, so bearing Y. Assign glyph metrics. We're gonna do the same thing for the size. So size X and size Y. We'll just go ahead and delete that. Size X, size Y. And those need to be bitmap width and bitmap rows. Width and rows. Okay. So that's enough for gathering the information. Oh, where's that? Bitmap dot width, bitmap dot rows. Okay, fine. Dot. There we go. You happy? So that's gathering the info. We also need the texture ID, which we don't have yet. So what we're gonna do is just delete that. Texture ID equals, and we'll say 0 to do fix me. Oops. Hey, Fade. Okay, so now we need to actually create the texture and blit it. So, hey, Gun. Create the Glyph Texture. So we're going to copy some of what's being done here. So we need to have a texture ID, and I can go ahead and just predefine a variable for that. So it's an unsigned int, uint. 8t. I don't know. This may actually need to be a 32-bit int. I'm not sure exactly what the size is of a texture ID. In fact, we can probably find out. texture ID. Also, I should probably just go look at what I did in the texture.c file. Texture ID, unsigned int is what I use for that. I'm guessing that's 32-bit. Yeah, let's stick with that for now. Also, let's make that 0. Okay, so now let's see. We need to go and create the texture. So we're going to use gen textures to create a new texture and get the texture ID for it. We're going to bind it, and then we're going to, well, let's just copy all this stuff. We need all this anyway, so I'm going to copy everything up to here. All right, so this creates the texture, and I'll put texture ID there. Bind texture, texture ID. I think it's happy now. I probably need to pull in the GLFW header. Where is that? Let's see, graphics.c. Let's pull in this header because we need to have OpenGL types available to us. Oh, we haven't got back to that yet. Okay. All right, so we have GL text image 2D, which is Adrishell. Setting up the texture information, the width, the rows. I mean, kind of feels like, hey, Gavin. Feels like we need to reorganize this slightly. In fact, I think we can actually get rid of the intermediate texture ID as well if we do this instead. So what we're going to do is current care. We'll call that care ID. No, let's not do that. Let's rename using eglot. Eglot rename care ID. Okay, I think that should do that for everything here. Good. And then Flux font care. Current care. This is going to be a pointer because we're going to hold on to the current character by saying current care equals Flux font cares care ID, and we need to get the reference to that as well. Okay, so assign the let's just say that, assign that. And then we can change this code to all be, oops, okay, that's fine. I'm probably not doing the most effective Vim editing style here, so tell me if I'm doing it wrong. Current care, whoops, current underscore care arrow, all right, so we're doing that. Just put that at the beginning of every line there. Yep, okay. Hey, Echo and Nicholas. Nicholas says, are the questions about this Emacs config out of scope? No, definitely not out of scope, but let's get this working first, and then we can talk about the config a little bit. Okay, so we're setting texture ID to 0. Let's just let that be the case. In fact, that should already be zeroed out, so we don't need to do that. We can do this, though. We can say current care, arrow texture ID, and then here we're going to use current. This should work. If it doesn't work, then we're going to have to debug a little bit. All right. So what do you not like? uint8t, aka unsigned car, to GLU int. All right, so it actually wants an int-sized thing for texture ID. Did I not change that? Ah, apparently not. Okay, that should be happy now. Don't need that anymore. All right, so now we have already started assigning things here. Which means we can get rid of some of these things that we have. We can actually speak in terms of what we use in our own. Let's see, left top. So this should be width and height. Current care. I keep doing arrows when I don't want to. Care size X. This needs to be Y. Yeah, Porv. Okay, so let's get that one done, and then we can pull the buffer. So this is something we'll have to use the face glyph variable for. So this bitmap.buffer actually contains the image data for the glyph. So that's what we're basically putting into the texture by calling text image 2D. And then we are, let's see, create the texture and copy the glyph bitmap into it. And then set texture options to render the glyph correctly. All right, and that is basically all the code. We haven't tried it yet, obviously, but that's a good start. So that should allow us to load a font. Now let's go back to graphics.c where we want to load this thing up. And then I can say, did I have a variable for that yet? No. So Flux font, Jost font equals null. Okay. Then we'll go back here. Jost font equals, and then we can pull in this whole ugly path that came from Geeks. And then also, I'm going to say a font size of 200 because on this machine with the super high DPI, it is kind of needed to speak in those terms. I hope this works. It would be cool if it did work. All right, so we've loaded the font. That should be enough. So I guess all we have to do now is just run the code and see if it totally crashes and burns. So let's just do that and see what happens. All right, segmentation fault, of course. So we will use GDB and see what's going on there. Let's see. Good GDB. And for this, I want to run Flux compose example/init.fxs. All right, so now we're in GDB. I can type run. What happened? Not a core dump. That's not what I wanted it to. Okay, I think I haven't put args in here before, and I need to use a different syntax to do that. So let's try running good GDB. And then --args, I think it is. Okay, quit. There we go. Okay. Nope. What? Okay, let's check this out really quick. So, GDB pass args to program. Probably I could just say help here and figure that out also. So help running. No. All right. Yeah, GDB --args. Oh. Okay. So maybe it's just a slightly different formulation there. Let's try doing this instead. So I will say, instead of full name, I'll say args. Unable to find, whoa. Okay, there we go. Segfault trying to reach into the bitmap.width. Interesting. And where is that? Is it the first thing I'm trying to access? Width. Okay, so something it doesn't like there. I saw something else get written out before. Unable to find libthread-db's matching thread library. Okay, I don't really care about that. Huh. Interesting. So, do we need to check anything else whenever we try to load a glyph? I don't see anything being written out saying that it failed to load it. Let's see. Maybe I'm... Oh, hold on. Let's say care ID here. Face has been loaded. Who knows? Maybe the font size it doesn't like, or maybe... I mean, it must have gotten the font loaded. Because otherwise we would have seen an error. Let's try it one more time. Oh, did I compile the code? Of course not. Let's try to run it one more time, see what happens. Okay, obviously segfault. But no logs written out to tell us anything that happened there, so kind of strange. Go back to good GDB, or good shell, I suppose. All right. So the question is, which part of this is not there? Is it the face or the glyph? So let's do a little bit of spelunking, I think. Uh-oh. Yeah, quit out of that app. Yeah, quit it. Okay, so let's double check face. So if, well, I guess I could have done that in the debugger, but let's just do it here anyway. Yeah, if face equals null, we'll just say no face. Okay. Otherwise, what can we write out about a face? Just in case there's some information. Face. Maybe there's like something I can write out as a string. Face. Let's see. Face flags. Family name. Let's try that. Just as a way to get some kind of indication there was progress. Recompile. Oh, come on. Let me just go back and do that again. Okay, face Jost star. So it actually did load the font face, which is good. So the question then is, why is the glyph not loaded? So maybe let's do a little check on the glyph at this point. So glyph bitmap seems to not be initialized, but maybe it's glyph itself that's not initialized. So we're going to check face glyph. No glyph. Otherwise, we're going to see what we can pull out of the glyph. Format, library, metrics, num subglyphs. Hey, Brian. That's a vector, huh? Is that just a normal struct? Okay. Advanced.x. Let's see. I'll put a D there. So is it bitmap that's the problem? Bitmap. Oh, hold on a second. Wait. Maybe it's the way I'm actually using current care. Is current care wrong? I should have just checked that in the debugger and see what happens. Let's go back into good shell. We're going to run the debugger one more time. And let's see what happens when we do this. So p current care. I mean, that seems to be a memory address, but it doesn't look legitimate to me because, you know, who's ever seen such a short memory address? So let's check it out. Size X. I mean, it should return 0 if it's set up right. Yeah, can't add access to memory. So that's definitely the problem here. Why is this returning the wrong thing? So Flux font. Let's make sure that Flux font actually did get allocated. We malloc the Flux font. We memset it to 0. Memset, what does it want? I wonder if I did something wrong there. Let's double check things. Oops, quit. I'm typing it like it's a scheme debugger. Okay, so let's look at memset other locations at header. Okay, so it's the same. If you have a pointer, then you want to use memset on that. No. Not right. That's wrong. I think that needs to not be an ampersand because what we're doing is getting the memory address of the pointer and not the memory it points to. So let's change that. Why is this unhappy? size is based on a different type. Oh, okay, sure, whatever. So back in the compilation buffer, this might actually fix it. What's not happy? Bitmap. Okay, fine, whatever. We'll delete that anyway. Okay, segmentation fault again. So let's go back in the debugger and see what else we can find. Run good GDB. Run that. So we get to, oh, all right, so this is different. What about the backtrace? Where are we? Load glyph? Am I asking for something that doesn't exist? Okay, so, So Flux font load file, what's the command to go to a specific stack frame? Help stack? Frame, okay, so F. I wanna go to frame number 5. Yeah, so let's go to F5. And what is the care ID? P, care ID. Okay, that seems legitimate. I mean, what's the problem there? So I called ft load care for care ID. Okay, let's just print it out here. Flux log loading glyph or care C care ID. Oh, wait. Oh, this is wrong here too. Care ID. Let's put a little, oops. This code formatter does some freaky things whenever you have syntax problems. All right, we'll quit out of that and close that window, and then we will run the compiler again. Okay, glyph. What am I writing? Okay, the advanced information. That's fine. Let's not write that out because it's a lot of noise. Okay, so we're making it all the way through the basic punctuation, and then somehow we hit a character that seems to give us nothing, or gives us an error of some sort, which is very strange. Doesn't return an error though. The Flux ft load care doesn't actually return anything that indicates there was a problem. So what is it that we're hitting? Let's look at the ASCII character table again. Right after the close bracket question mark? Come on, question mark shouldn't be a problem. Oh no, that's the angle bracket right before that happens. We're getting a glyph every time. Well, let's put this back in for a second. Okay, so it never gets to this point where it writes out that glyph message, which means that in here it is choking. Why would it crash? That seems so bizarre. Okay, so FreeType, segmentation fault, ft, what is it? ft load care. Fade says the next character is slash. No, I think it's a question mark. So there's greater than question mark, number 63. But I think 62 is the one that it doesn't even get past. It hits that greater than sign and then crashes out immediately. Let's see. Care 60. Let's see. What is it? Oh, yeah, you're putting in Emacs character syntax. Character literal syntax. Okay, let's see. What was I looking for? Ah, yeah. It was 60 what? 62. Okay, that doesn't help. I don't know what that is. Interesting. Okay, so let me see. Maybe what I can do is just skip number 62 and see if it happens elsewhere. So if char ID equals 62, continue. Terrible thing to do, but we're going to do it just to see if it is a specific character that's a problem or if it's just anything after that point. Okay, so even that glyph right after, which is a question mark, is crashing. That's very strange. Okay, so maybe what we'll do is start at A. I'm just curious to see what happens if we start at A. Oops, that's the wrong one. Compiler, where's compiler? Compiler, where is the compilation buffer? Disappeared. Okay, so compile. Oh, I have to go back to top level folder, compile. Come on, compile. That one. All right, A, B, C, and then segmentation fault. I got a feeling that there must be some memory management stuff I'm not doing correctly. So maybe we need to go look at the documentation for the FreeType library, because something's wrong here. This does not feel right. It feels very arbitrary when it decides to crash on certain characters. Makes me wonder what is actually happening. So one thing I'll do here at the end, just to make sure everything is good and cleaned up, I'm gonna clean up the face. Clean up the face. Or let's see, free the face. All right, so anything else they mentioned here that we're not doing? A lot of other stuff we don't really need. Vertex buffer objects, don't really need to deal with that either. Okay, so FreeType library. We'll go take a look at the documentation to see what might be going wrong. So FreeType tutorial. Suppose you could do API reference, but maybe tutorial is the most effective thing to use at this point. Accessing the face data. Num glyphs. Well, I guess we could take a look at that also to see what the face tells us, how many glyphs it has. So after we load the face successfully, we can say face has, is that right? Yeah. Has D glyphs. Okay, face S has, sorry if you hear my daughter screaming in the background. She's resistant to taking naps at school now, so she's acting very nice as a result of that. Okay, glyphs. So we're gonna have the family name and face, num glyphs. I think this is the name. Yeah. Okay. That's a long. Okay. LD. Maybe I need to put there. And what else? Face data, face flags, num fixed sizes, setting the current pixel size. Pixel size. Yeah. Set char size. So what were we doing with set char? Oh, set pixel sizes. Okay. So we don't need to worry about that one. Set pixel sizes, pixel width, pixel height. Handles with the face object. So we're doing that okay. Converting a character code into a glyph index. They have character map stuff, which we're not really dealing with at the moment. Loading a glyph from the face. Okay, FT load glyphs. That's the one we're calling, right? No, we're calling FT load char. So let's look a little bit more closely at that one. Face glyph index. Okay, so that matters if you are pulling the glyph based on the, oh, hold on. Yeah, the character index, which, I mean, maybe we have to do that. I don't know. Care code in the care map is currently selected for the face. You should use the UTF-32 representation form of Unicode. Render glyph. Format describes the format used for storing the glyph image in the slot. Using other care maps. So I don't see anything about, what's this, the FT load care, but we can try to go to the definition. Okay, so this function simply calls get care index and load glyph, which is what we would have done otherwise. Many fonts contain glyphs that can't be loaded by this function since its glyph indices are not listed in any of the font's care maps. If no active CMAP is set, the call is omitted and the function behaves identically to load glyph. Pedro says your mouse pointer looks tiny on the stream. Yeah, it looks tiny to me too. I need to fix that. All right, so if no active character map is set up, the call is omitted. So there must be glyphs though, because I use this font all the time. And I imagine it has glyphs for the standard ASCII characters, so I'm kind of confused. Load no bitmap, ignore bitmap strikes when loading. Okay, there's a lot of flags for font loading here. Let's see, which function is this actually? Ah, okay, so all the flags. Let me double check some stuff in the code we've done so far. Did we have anything that says bitmap in it? Okay. FT load render. Okay, and let's check that out here. Where was that? FT load render. The glyph is rendered in the corresponding mode. Okay. Okay, so back to what we were looking at first. Excuse me. FT load care. FT load care. So I guess the question is, should we call FT load glyph first to see if there actually is a glyph? Just to double check. FT load glyph. All right, so we'll try that really quickly and see if it returns a glyph, because that could tell us whether this is a problem. And we'll put that right around here. So let's just load the glyph. FT load glyph. It doesn't matter if we do it twice. Okay, so we'll run this again. Okay, so it didn't give us any error, apparently. Oh, yeah. If it's non-zero, yeah. Load flags value. FT load render. I wonder if the render flag somehow is a problem. That would be really weird if it was. So what if we put 0? I don't know. Probably a bad idea, but let's just see what happens. Oops, I think I went too far. Okay, so let's recompile. Same problem. So that doesn't seem to be the issue. Very, very strange. And we don't have a problem until we get down to... Oh, no, wait. Hold on. Let's do this. Just to make sure we know that it got loaded or not. Okay, so it did not get loaded for C, which is very strange. I mean, a font obviously has to have a capital C glyph. Okay, let's try one other thing. Let's start this at B and see how deterministic it is. Does it stop at C or does it stop at D? Still stops at C. That is freaking weird, man. What is happening? And it's literally crashing inside of that function somewhere. So I guess we have to dig into it a little bit further with the debugger, which seems like a terrible idea to me, but let's see what we're gonna do here. All right, so we're gonna run it. Okay. So BT for backtrace. TT run INS. What is that? Locals, is that right? Info locals. No symbol table, of course. Makes me really wonder what could possibly be the problem. Because we're giving it the same face every time. Okay, so how about this? Maybe we should try a different font face, just in case. Also, maybe we could try a different font size too. So I'll go back into graphics.c. We're going to change this to 20 instead of 200. I don't know if it's going to help, but we're just going to try anything right now to see if we can invoke different behavior. Okay, so that didn't help at all. So then let's just try a different font. So let's just paste this so we can hold on to it. And then I'll go back to my GNU store. I may have another font sitting around that we could use if none of this works. All right, so font Liberation, maybe. Let's try that. Liberation Sans Regular. Sounds good. We're gonna go into the, let's just go into graphics.c. And we're gonna put this here. Whoa, that's not what I meant to do. Go into DRED. No, what's it called? TrueType. There it is right there. Okay, so copy that line and delete the garbage. Okay. Go back to the slash, paste that, delete this up to the quote. Then also we need to grab the right store path for this, which we're going to do right here. Just paste that in, delete it up to the colon, and then let's delete that up to the end quote. Then we'll take out the font's TrueType part of that as well, and make sure we put the trailing slash. Okay, so that's enough for that font. Let's run it and see what happens. Wow. Does it actually give me the right font? Something very strange is happening. That's two different fonts that have failed in exactly the same way. Let's see what happens if I go back to font.c. Something very specific is happening here. Start at ASCII char start. Because before it was failing at the greater than sign. And it's still happening at the same place because we have this little skip here that does nothing. Okay. So whatever the problem is, it is consistent across different fonts, which is a very interesting characteristic of what's happening here. Let me just double check over the code. Can I see like a finished file for this? No, apparently not. Make sure I didn't miss anything. I mean, we haven't even got to the code to create the texture yet. Still very, yeah, I know. I was in GDB. You should see the stack trace. We basically just lose visibility completely. Let's see. Oh, I didn't put that in. That's obviously not going to matter because it has nothing to do with what we're doing. So let's do this. Okay. To do I need to reverse this afterward? Okay. Obviously that doesn't have anything to do with it, and if it did, I would be very confused. Yeah, so we're still in the same boat. Let's do this too. Size of Flux font. Are you happy? No? Still not happy? Oh, struct. Jeez. Okay. That can't be the issue either. Interesting. All right, we'll go back to what we had before there. I think it's giving me a diagnostic for that. Am I loading the glyphs in the stack? I don't know. I don't think so. But it's a good question though. So FT face, what is that? Yeah, okay. So that's basically a pointer. It's a type def pointer. All right, for my my debugging partners who have arrived. So what we're doing is we're loading up a font face using FreeType, and we're now trying to load character glyphs. And for some reason, at some certain point, which is very consistent, happens for 2 different font faces and different font sizes, we get a segmentation fault inside of the FreeType library. And I'll show you what that looks like in a second. Let me go back into GDB. And I'm going to run GDB again. Type run. So take a look at the stack trace. So we're in FT load glyph, which is what I'm calling, and then it just goes into some unknown symbols, and we can't get any information out of those. So let me, well, okay, so the first one is a pointer, Ashraz. I'll tell you in a second. And you can tell me whether this is a terrible idea for how to model this stuff. Come on. So we're just gonna quit that process. So, Jesus. All right, so let's see. Where was I going? I was gonna show you the Flux font. Flux font is actually a type def struct pointer. So that's why you don't see the star there. It's actually a pointer already. So we're using malloc here and allocating but this is maybe the wrong thing, is allocating the size of Flux font. I doubt this is the issue. Wait, hold on. Is that right? I want to dereference the actual. That's not right, is it? Malloc size of struct Flux font. Okay, struct. Yeah, maybe that's safer. I'm gonna be really confused if this is actually the problem. Quit. Oh my god. All right, let's go back to compilation buffer. Interestingly, okay, so we've made it all the way to the end, it seems. I don't know why there's a seg fault there, but okay, so Ashraz solved the mystery. Let's see what else you wrote here. Okay. Reverse step. Okay, cool. I'll try that next time whenever I run into such an issue. I think this also needs to be improved. But I think it did something strange, didn't it? Oh, maybe that's why it did something strange, is because it didn't have access to enough memory whenever it tried to zero it out. Okay, so we're still in the same place. Good. We got to the tilde, which was the end. Apparently we've been loading glyphs for all these, which is good. It means we must have been creating textures. So why then do we end up with a seg fault at the end? Size of star Flux font, is that gonna work? I was thinking that, oh, at this point I guess it's fine, right? Yeah, so at this point it's fine because there's actually something there. Okay. Core dump limit removed. You can use GDB with an existing core dump. Yeah, okay. Yeah, I don't have system D. I'm on Geeks here. Okay, so let's figure out what's happening at the end. GDB. Maybe GDB can tell me something useful this time. Still in FreeType. List finalized, done face. Okay, so when I try to free it, for some reason it freaks out. Is there anything else I need to try to free before that? Yeah, it would be better, I guess, if it was just dumping core and I didn't have to go restart the program every time. Okay, so calling done face here seems to be an issue. Now that I know this is going to work, let's go back and load the original font that I wanted to load. Let's see if that works. I'm pretty sure it will be fine now too. Okay, good. Done face. Okay. You must not deallocate the font file buffer before calling ft done face. Yeah, okay. Well, okay. Let's just let's not free the face for now. I'll have to figure that out later. We got 30 minutes left. Let's see if we can get something rendering on the screen at least. I would prefer to have something happen before the end of this. Ashraz, I have no idea what libasan is. If you can tell me what that is, it'd be helpful. Or tell me afterwards. Okay, so if I just take the free out. Yeah, okay, so we're back to rendering again, which is great. So to fix this, what else we got here? Did I do anything else stupid that needs to be removed? I don't need to do the glyph loading again because it happens already with the load care. Address sanitizer, okay. Okay. I can leave this log message out. All right. So now we should be able to go render some stuff. So what we'll do is make a function. I might not actually need to. So the question is, do I put this stuff, the font rendering code inside of this function, sorry, inside of this module, I guess you could call it font.c. I guess we'll put it here now. If we want to move it somewhere else later, we could do that. Flux font draw text. I'm gonna make this a void function. And whoops. Then I'll have a float position x, float position y. And then we need to have a flux font as a parameter. And also a const char string. Or let's say text. How about that? Text. Cool. So that is our function that we're going to use for drawing text. I can go ahead and start using it now in, well, no, let's put that in flux.h right there, extern it. And then go back into graphics.c and we'll put it right after we draw the texture. So flux font draw text. We're going to use the Jost font. We're going to say flux harmonic. Position X, Y, we'll call it, let's say, I don't know, 20 and 20, whatever. We'll tweak that in a moment. Okay. So draw some text. And I think that should compile and run just fine. Okay. So it doesn't do anything yet, obviously. Font.c. So we may not get the whole thing done today, but what we're going to do is at least try to draw the first character on the string. Of the string to the screen. So let's start with that. So Sterlin, maybe there's a more safe version of Sterlin I can use for this. Text. let's see. We want to have a uint 8t, or no, is it like what size t? What does strlen return? Do I have string.h? Why are you not telling me anything? Oh, because of that. Num chars equals 0. Give me some help here. I don't know if it's size t. Could be. Num chars. Num chars. I may not even need this, but, you know, let's go with that for now. Just, you know, C string handling is fraught with peril. I guess string length probably is not one of the ones that is necessarily dangerous. So the number of characters, what we want to do is do a loop over the number of characters, uint 8ti equals 0. I keep initializing variables at the top of the function because some of the compiler flags we have set yell at me when I define things in line, so that's why I'm avoiding doing something that seems obvious. The string is not null terminated, there's nothing you can do. Yeah, that's a good point. So for I equals 0, I is less than num chars, I plus plus. All right, so for each of these characters, we're gonna get the char out of there. Char C equals 0. Ah, yeah, it's gonna just, you know, give me a very nice long number. At some point, it'll find a 0 or seg fault. Ah, haha. Thank you, Pedro, for catching my obvious stupid mistake. Okay, so here, get the char information, render it. Okay, so from the font, we want the chars, and we want I. In fact, that's fine. Let's have a pointer. Flux font char. Is that the correct type? Yeah. Okay. Flux font char. Current char equals null. Okay, so we're pulling the character information out, and all we're going to do at first, we're just going to render the texture to the screen. So we'll follow what is being done in this tutorial. I'm not going to bother with anything aside from setting the active texture. What is that? GL active texture, texture 0. The text color. Okay, cool. Don't need that right now. We might need it. We'll see. Bind texture, is that right? Bind texture. Okay. So GL bind texture. GL texture 2D. And then we need the ID, I think. Yep. So current char texture ID. Double indirection. No, chars is a it's an array, like it's a pre-allocated array of the number of characters that we would store. So if you look at this array right here, we're basically just saying whatever the end ASCII character we want to represent to the start character, just however many numbers there are there, we're gonna have the number of chars. Oh, and there's something else I forgot. Oh, no. Yes, actually I did forget that. I'm kind of surprised we haven't hit an issue with that. Oh. Okay, so one thing I forgot to do here, I think, was to subtract this from ASCII. What was it? ASCII start char? ASCII char start. Where's that? Because that needs to be 0 based. Interesting that we didn't have any issue with that. Point to Flux font char instead. Oh, you mean just a pointer directly to the first entry? Okay, exited abnormally. Probably got some issue in the later code. Invalid initializer, line 98. Come on, 98. Needs to be a pointer. Okay. And why are you upset? Ah, need to have an ampersand there. Okay, now build it again. Okay, ooh, interesting. Oh yeah, we're not clearing the texture afterwards, so it messes that up. Flux font care, yeah, I could definitely do that for sure. Felipe is suggesting doing some pointer math instead of using the array here as well. I mean, we could try it out in a second. So I need to clear the texture afterwards, because otherwise we're going to end up bleeding into other renders, which is what you saw there whenever the rectangles disappeared. So now if I run this, it should be back to normal. Okay. And then we want to draw this to the screen. So I need to, let's see. It's using vertex buffers for this, but I don't really know why. I guess for performance. I'm not going to deal with vertex buffers though. I'm just going to use plain old quads for now. We can make it faster later. So graphics, draw texture. And then what we did here was use GL quads. And then GL end, obviously. And then we'll just copy this a little bit and drop it back in there. So for the texture coordinates, we're just going to draw a rectangle effectively and use the expected texture coordinates. So vertex 2F, we have the character width. So what we can do is, let's see, where's the start position? We have position X. So we're going to say pos X. The missing pointer decorator one. Don't know what type defs and structs are. What pointers? Yeah, for sure. Yeah, that is one of the tricky parts of doing type defs or pointer types like that, is that you don't know that something is a pointer just by looking at the code. Which, you know, I'm very willing to hear other theories on how to do that better, because I'm obviously not an expert C programmer. I'm just sort of doing this on the fly. Haven't written C code in many, many years. All right. Just mechanical editing right now. Position X. Yeah, I know this is probably excruciating to some people who are wondering why I'm typing all this stuff out like that. Okay. Make sure I didn't put X in the wrong place somewhere. All right. And then texture. We're just going to replace that with current care size X. I guess I could say width there. I don't know why I put size X. Felipe suggests just avoiding type defs. I mean, it's certainly a possibility. I mean, I guess it ends up with, you end up with better, or more obvious code when you do that. And I'm kind of with that idea. All right, now I'll just copy this and drop it down here, and maybe we can get one letter rendering on the screen. We'll see what happens. Or all of them rendering on top of each other is the more likely scenario. So how about this? I is less than 1. Let's do that for now. Is this gonna work? No. Let's just comment this. Whoa, what just happened? All right, so if I is less than 1, then keep going. All right, let's see. All right, so we're not seeing anything yet, but I wonder if I need to set a different color for rendering. What am I rendering at that point? Let's set the text color to yellow. And I'll do that in graphics.c. Right before calling draw text, we'll set the draw color. Okay, that's setting it to white. That's fine. Let's just leave it like that. So maybe I need to double check that I'm not missing anything else. GL end. I don't need to pop the matrix. Bind texture. Okay, all that seems fine. Let's make sure we're actually rendering something. So Flux log just rendered a character. Because maybe we didn't even make it inside this loop. Who knows? Okay, so it did try to render something, but it's not actually showing up on the screen yet. So what if I don't bind a texture and let it just draw a rectangle? So no rectangle either. Let's check the information about the character and see what it is. So D current care current care size X, current care size Y, just to see what that prints out. Zero, zero. No wonder. What did I miss? So size X and size Y should be pulling this information. I'm kind of interested in why. Let's see. First of all, what character are we drawing? Let's find that out first. I mean, I know what I put in the string, but we need to know what it's trying to look up to start with. So hold up. Yeah. Wrong. Totally wrong. That's why, because we're only rendering a space. So what we need is text of I, right? That's got to be the reason why. Let's start with that. Okay, now we at least have a rectangle, which is a great sign. It's got a negative height. How is that possible? All right, so that's good. We have a rectangle that's being rendered. Now let's see if we can render the texture, actually. What is that supposed to be? That's something. It's not, it doesn't have an alpha channel. That's a little bit annoying. Let me think for a second. So it seems whatever character we have rendering is doing it at the wrong place. I don't know why this is a negative number, though. That seems very strange for it to be negative. So it kind of breaks all of my logic. Why would it be negative? Let's double check this. So they have size Y. They're pulling in the rows. And it's also drawing it red. Why did it do that? I see that red in the code. I don't know why it says red here. Unless I'm rendering it red. Hold on a second. GL text image 2D. Okay, internal format. Oh, come on. Level internal format. So what is red as an internal format? That doesn't make any sense. Unless I'm missing a step they're using later in the texture rendering. Oh, you know what they're doing? They're probably using a shader to deal with that. That's annoying. Okay, they have GL red. Do they have GL white? Nope. Okay. Well, we'll proceed for the moment. I think that the letter I'm using is F, and I have no idea why it looks like a backwards J. That can never be anything other than, or it can't be an F. All right, let me zoom in on this a little bit. Scale. Where did I have that? Yeah, let's make this bigger so we can actually see what's going on there. Oops. All right. Zoom in. Yeah, that something strange is happening. Trying to think of what else could be going on with that. First of all, I don't know why it's negative. Did I do anything in the code that would have coaxed it to be negative? I'm just setting the variable. Using bitmap rows, we can write that information out. Let's see, flux log. Glyph size is D. Current care size X, current care size Y. Is it because it's unsigned? That can't be right. Oh, you? No, hold on. How did it even show up? Oh, it is it's a signed integer, fine. Okay, so we got that. And also I want to get rid of this line that I'm writing out so we don't get distracted. Okay, so there's a bunch of them that actually have negative heights and negative widths. I just don't get it. Okay. Okay, nothing about that. How large are the fonts? Well, this one I've made it pretty big just because on this screen it needs to be big. It's high DPI screen. I can try to make it smaller. Let's see. Go into graphics C. I don't think it would have been so big it would like overflow the integer though. That wouldn't make any sense. So we have this right here. I'm gonna set this to 20 instead and see what kind of numbers we get out of it. So let's see, any negatives in here? Aha, well, who knows? Oh, you know what? I'm stupid. It absolutely did overflow the integer because I'm using uint 8s, which now just seems like a stupid thing to do. Because it's only what, like 256? Yeah, that has to be it. That's hilarious. Okay. Oh, did it render? I didn't think to check. Okay, it did something, but that still doesn't look right. At least the output is a little bit more reasonable this time. All right, we'll put it back to 200 again because I want to see this change actually make it work. Where is it? Font.c. We're going to change this to int 32, 32. I'll leave those as 8 for now because I don't think those are going to be that big. But, you know, can always be the case. Oh, segmentation fault now. Why? That's really freaky. Okay, so we do see some numbers that are big enough that obviously, you know, it's better to not use an uint 8. Let's do this too. I don't know. I don't know why it's crashing now. Unless... Okay, I'm probably doing something wrong somewhere else. So am I hard coding int 8 anywhere else? Not there. X. Font size, okay. All right, so GDB time. Linear to Y-tiled faster. Okay, so something I'm doing with the rendering is causing the problem, it seems. There's like a driver thing going on now. Oh yeah, it's in the Mesa drivers. Awesome. Let's see, render loop. Say what? So it's in the font loading. Okay, let me make sure I'm not doing something really dumb there. Oops, in this one I want. Let's quit. Yes. Close that window. Back in font loading. So that's an unsigned integer. What is this? ftint, also unsigned integer. Go to the definition. It's got to be a normal int size. Okay, let's just for the sake of not doing something stupid, we'll change those also. And we'll also change the advance also. Also. Not gonna fix the problem, but now what else? Something I'm doing with textures here is causing issues. I didn't change anything here. Oh, wait. This is wrong. That should be Y. Aha. Hey, there's an F. Cool. So that's a good start. However, that's a lowercase f, which is not what I think I wrote. I think I wrote an uppercase F, so kind of interesting that it did that. So we got 5 minutes left. Let's just try really quickly to see if we can get the actual full string to render, because I'm kind of curious to see if it will work. Okay, so this time I'm going to go numchars. And I'm also going to increment position X at the end here. Pause X plus equals the width of the character. I mean, that should be enough, right? So current char size X. We're going to get some weird output, I think, but at least it will tell us whether the things are working right. Whoa. Wow. What is that? Yeah, bad memory access can definitely show up anywhere, that's for sure. Okay, so text I. Interesting. Let's just see that I'm getting, reasonable output. So some of these have 0 as the size Y, which makes no sense. Bunch of garbage in there. Yeah, I'm getting there slowly but surely. Yeah, some of this stuff makes no sense at all. Like, these sizes are too big. Why is that the case? Maybe this needs to actually be like what Felipe said. Font chars plus I. Is that right? No. Yeah, that's... No. Wait, hold on. That's still wrong. I think that's the problem. I did something really stupid. It needs to be this minus Ascii char start. Let's try this. Maybe that works. Hey. All right, so we have text rendering. Now I see that the problem is we are not actually respecting the parameters for each glyph where we place the characters correctly, but it actually works. We did render a string, so I'm going to call that like an actual win. But for the next stream, what we're going to do is clean this up, make the color show up correctly, get all the letters aligned correctly. And also, I mean, like the spacing doesn't look perfect on these, but that's obviously because we're not, dealing with the bearings or anything, or the advance, I guess, is another factor we have to put in there. But at least we did manage to load a font, render all the glyphs to textures, and now we're drawing it to the screen. So I'm pretty happy with the result of that. And it looks kind of interesting, like some kind of weird, punk rock album cover at this point. And let's see if that did render out to the output.png file. Whoa, okay, so the output PNG looks really jacked up. I'm not sure exactly why that's the case, but something for another time. Okay, let's go back to our task list. Did that, and did that. So the next thing we're gonna do is these other tasks. Also, another thing that I will try to do at some point here is render all the glyphs to a single texture atlas for performance. So instead of having individual textures for every letter, I would have like one big texture that I'm basically just laying out all the letters and then using texture coordinates to pull the right location. That way, for every letter, you don't have to switch to a completely different texture, which should reduce some of the context switching in the graphics pipeline. And then later, even try to bake a texture for static text strings. So if you aren't going to change the text in the string, you might as well just render an entire texture for the entire string, and then you don't have to do any of this recalculation every time or every frame, basically. So there's some performance stuff we can do. We may or may not do that next time, but at least we have a good starting point. Oh, we also need to find out how to make the text white instead of red. Okay, so like I said, pretty happy with the result there. And then, yeah, on Thursday, we'll be back at the same time, 3 p.m. UTC, to hopefully finish what we started here today. I mean, by the end of this week, we'll definitely have font rendering working. I mean, we'll obviously see it working now, so I'll clean up the rest of it off stream. And then we'll forget what we do the following week. So anyway, thanks everybody for showing up today. I really appreciate your help. Especially appreciate Felipe and Ashraz and Pedro for seeing some pretty key issues in the code to help me get unblocked. And until next time, keep creative. We'll see you.